on behalf of all of us at FIATech, I'd like to thank each one of you for joining us today for what marks our 81st live webinar broadcast. Today we have an exciting hour set aside to discuss DPR construction success at real-time supply chain management using virtual design and construction and lean principles, for which they were recognized in March with the SETI Award in the Integrated Automated Procurement and Supply Networks category for this achievement. Before I introduce today's speakers, I'd like to remind all of you that FIATech is a member-based organization that brings together companies to accelerate the deployment of technology in capital projects. We have over 60 member companies, and we're always looking for new ones to join our growing consortium. So if you are interested in joining or would like more information on the group, please drop me a line at ntboston@fiatech.org. Or if you have any ideas on future topics for future webinars, please let me know that as well. With that, I want to go ahead and welcome and introduce our speakers. Atul Khanzode leads DPR's Construction's Virtual Building Group and works with project teams across the country to implement virtual building and lean construction tools and processes with more than 15 years of experience in the construction industry. Atul has worked on healthcare, biotech, and advanced technology projects for DPR's construction in the last 10 years. He has focused on last 6 years helping DPR leverage advanced technologies to improve critical business processes. Joining him today is Sangwoo Cho, who is a senior BIM engineer focusing on virtual building and supply chain management, lean process, and real-time data capturing tools. He's a PhD candidate at Stanford University doing research on supply chain management using virtual building and lean principles. His specialty is model-based implementations such as MEP coordination, estimating, last planner, field BIM, and constructability review on various types of construction projects such as healthcare, commercial buildings, and advanced technology. Sangwoo and Atul, I want to thank both of you very much for joining us today to share with us your case study, and I'm going to turn it over to you at this time.
Okay, thank you, Nicole. Welcome, everybody. This presentation is about sort of supply chain management using virtual design and construction as well as lean principles. So Nicole has already introduced us, so I'm going to skip this. We are both PhD candidates, as Nicole said, at Stanford, and both have interest in sort of VDC and how lean and VDC work together. Just before we get started, a really brief background about DPR. We work in four core markets: advanced technology, healthcare, life sciences, and corporate office. This is our third FIATech SETI Award for the supply chain management, and currently have about 75 to 80 projects across the country that are in various stages of utilizing BIM for a variety of purposes. And you can see the ENR. We have been in the top 50 for a while now. This is sort of our footprint. We are, if you draw a smiley across the U.S., that's where we are. Mostly California. We are also on the East Coast, in Mid-Atlantic and Florida, as well as the Southeast. So what we are going to talk about today is really this case study of how we utilized VDC and lean for managing the doors, frames, and hardware process. So unlike a lot of other general contractors, DPR also does a lot of self-perform work. So we focus on concrete, we focus on drywall, as well as finishes, and doors, frames, and hardware is one of those. We saw a lot of benefit in implementing the supply chain solution for doors, frames, and hardware just because of how sort of complex it is. It happens towards the end of the project. There's a lot of inventory management that needs to happen, and it's always at a crunch time when the project needs to be done or finished on time. So this project is for University of California, Santa Cruz, the case study that we are going to talk about today, and it's really how our project team used the real-time supply chain management and VDC and lean principles to manage this process. And this was also the case study that we submitted for the SETI Award, and that we won that. So Sangwoo is going to walk you through the case study, and I guess we will get to questions and answers towards the end of the seminar. So over to Sangwoo.
Thanks, Atul. Hello, everyone. This is Sangwoo. Today, before I talk about the new system and case study, I'd like to share our observations on our current practice to identify which problems can be resolved by using the new system. So our first case is that our communication in the construction supply chain management is fragmented and push-driven. One door-frame hardware project manager mentioned that closer communication between suppliers, field teams, and door-frame hardware project management team is the best prevention of future problems with supply chain effectiveness. Yes, this is very clear. However, when we observed our current practice in the supply chain management in the field, there was no effective communication tool, and there was no direct communication tool between suppliers and field crews, and between field crews and project management team. Also, typically, project managers talk to suppliers through email, fax, or phone call. And another thing to note is that the communication is even push-driven from upstream to downstream, along with the material flow. This fragmented and push-driven communication in the supply chain management in the construction industry results in higher possibility of misalignment between demand and supply, because suppliers' control on production and delivery is not based on updated weekly, daily work plans from the field, which we believe best reflects current progress of installation. So this misalignment between demand and supply creates an unexpected increase in inventory or work in process, potentially translating to overruns of cost and time. For example, additional cost because of the additional storage space and additional manpower required for maintaining the inventory and space. So we studied one door-frame hardware project case study regarding misalignment between demand and supply. And as you can see on the left bottom corner, the misalignment between demand and supply was average 7 days. For these average 7 days, the project team stored the material on site, which created some missing material and some QA/QC issues, such as scratches on the door panels, and potentially block workflow of another activity. However, as you can see, these 3D images, most of the construction projects, especially in urban cities, have very little space for inventory storage. So controlling material supply to meet our demand is one of the success factors to minimize additional costs. So is there any proposed solution? Definitely, we have to have a better communication tool between supply chain players. So we propose to utilize web-based last planner system, which is the registered tool by LCI, to enable two-way, web-based, and centralized communication. And we also want to use pull mechanism link concept to have the field crews report their demand directly to upstream, which is suppliers. And real-time data capturing tools such as RFID tag, barcode labels, tablet page, and mobile phone can be utilized for instant sharing of information about progress of a supply chain. Second observation is supply chain management has very low reliability. Let me give you one example. Field foreman is supposed to measure quantity complete on a daily basis or on a weekly basis. And he is also supposed to mark up on 2D plans with color pens to indicate which activities have been completed. So he typically measures quantity complete using a measuring tape or even visual inspection. Then he creates a quantity complete report to say, I'm about 30% complete, for example. Then he sends the report to a project manager so that the project manager updates his Excel spreadsheet or even bar chart for production and delivery control. However, this unreliable data captured in the field using a measuring tape and or visual inspection potentially creates distortion of demand information, which would create misalignment between demand and supply. Another similar thing is this reporting practice is manual-based and report-based. So there is a difficulty to share information among supply chain players. This difficulty increases latency of information sharing and decision making, leading to distortion of demand information. So we believe that 3D model, real-time tools, and loss planner system can resolve this unreliability issue. With the 3D models, we can do model-based quantity takeoff for accurate reporting of quantity complete. And real-time data capturing tools can assist the 3D modeling quantity takeoff process. And loss planner system can include very detailed description about resource, promise, commitment, and failure regions, which can be used for better understanding among supply chain players about what happened in the field. Our last observation was we had supply chain management had very low visibility. Another Dolphin hardware project manager mentioned that there should have been very clear visibility into potential change orders for better coordination of material delivery and manpower. As you can see, the table on the bottom, unexpected change orders in the field makes it very difficult to plan when and how much material is needed. Typically, about 2% of Dolphin hardware job cost is related to unnecessary change order. Unnecessary change order means I will receive the material, but I can find it, so I'm going to simply just reorder it. One Dolphin hardware project in Cupertino, California, spent about $6,000 to reorder the missing materials, and spent another $5,000 to bring the installers to site for additional days for installation. So we propose to use 3D visualization for supply chain management. This 3D visualization can help us monitor unexpected field conditions and increase clarity in communication and reduction in change orders, RFIs, and decision latency. Based on the three observations in the field, we believe that there is a need to develop a methodology and system to improve communication, reliability, and visibility by integrating VDC, BIM tools, BIM concept, and real-time data capturing tools to improve the match between demand and supply and to have less reduction, less distortion of demand information, and to have huge time savings. With this integration, we aim to achieving three major goals in the construction supply chain management system. First one is better alignment between demand and supply to lower inventory and work in process on site with better production and delivery control. And second one is less distortion of demand information to lower latency of decision-making process and unnecessary change orders. And last one is savings in time to increase time savings in recording, documenting, communicating, and reporting in the construction supply chain management. So here's an overview of our new system. On each phase of a supply chain, such as manufacture, ship, receive, installed, punch list, QA/QC, handover, commission, we scan a barcode or RFID tag on each material. And this scanned information is transmitted to our VDC BIM servers to create color-coded visualization on a project website. And the time log data from the RFI tag or barcode level and quantity complete data from the 3D models will be combined and inserted into our ERP system to create reports such as real-time status reports, color-coded 4D visualization reports, and updated daily or weekly work plans in the last planner system. To make a fair comparison between the current system and our proposed new system, we mapped out each step of the supply chain management using the both system, and then we did some time study. Through this streamline mapping, we identified which step could be replaced with automatic and reliable steps. For example, with the current supply chain management practice, every time materials are received or installed on the site, field foreman must manually review plans, update status, and then issue a paper report, which takes about 120 seconds per material. However, with this new integration system, field foreman can use barcode scanning to instantly assess material information on the tablet page and then update status by one click. And then output is automatically color-coded and then reported to project managers and suppliers, which takes about half time. So we decided to use this new integration system for one pilot project in Santa Cruz, California, and here's the case study. The project was UC Santa Cruz Co-op College B building, 6-story and 100,000 square foot. The number of the materials tracked is about 200 doors, about 200 frames, and about 2,000 hardware. This is the interface of the tablet page where you can check time logs of each material for manufacturing, receiving, installation, and QA/QC complete. Then those information will be transmitted to our project website, where all the supply chain members have access to check detailed status reports and color-coded visualization. This is the color-coded visualization on the project website. The supply chain members can check a real-time color-coded visualization to see status with each material with a detailed status report on the bottom of the web page. For example, as you can see, the 3D image, door of room 521 was received but not installed yet. So total completion percentage of the door installation is 65%, and you can check the color coding on each material to check the which stage this material has been. And on the bottom of the web page, you can check detailed status of the report for each material and total materials with the material schedule. Then the time log information from the barcode and quantity information from the 3D models will be transmitted to our web-based last planner system to update daily, weekly, and look-ahead work plans for better control over production and delivery schedule to increase better alignment between demand and supply. And this is the best tool to indicate our current status of the installation progress on the site. And this is the best tool to share information among the supply chain members. So with this new integration system, we achieved about 70% time savings in recording, documenting, communicating, and reporting, which is about 28 hours saved. And another benefit from this integration system was better visibility. Typically, we say, we think we are 75% complete. However, with this integration system, we can say we know we are exactly 75% complete, and which 75% is actually complete on the site. Another benefit was we achieved reduction in reorder rate. Zero unnecessary reorder was achieved due to no unnecessary change order related to missing material, which leads to less distortion of demand information. So we claim that the typical 2% job cost related to unnecessary change orders did not exist in this pilot project. We also recorded testimonials from end users, which are supply chain members. Their overall satisfaction score was highest, which is 5. With the new system, we accomplished everything in less time than ever before. And they can have a great picture of what can actually be installed in the future, and immediate visibility into change orders and into progress of the installation. And then they can communicate status of materials in a better way. And then they also achieved substantial time savings in recording, documenting, reporting, communicating. And project websites can be utilized for status check from anywhere and anytime. And then they finally foresee all the project progress in a more reliable way. I think our presentation is too short, but this is the last slide. The integration system of VDC Beam, Lean principles, and real-time data capturing tools has been developed and implemented and validated for better alignment between demand and supply, and less distortion of demand information, and time savings in recording, documenting, communicating, and reporting of the construction supply chain practice. These all benefits led to improvement of aspects of the construction supply chain management. So currently, there are some tools existing for integration of BDC and real-time for material monitoring and material tracking. And obviously, last planner system is being widely utilized across the nation for project progress checking and for improving project commitment. However, we'd like to make some integration between those tools with another new innovative tools to create our new methodology to help improve the aspects of the construction supply chain management, in such as better match between demand and supply, and to enable real-time web-based two-way collaboration among supply chain management, supply chain members, and to have a reduction in distortion of the demand information and savings in time and effort. So this is the last slide, and then we'd like to take some questions from all of you guys, and then we'd like to spend another 20 minutes for Q&A session. Nicole?
Sorry about that. I had you on mute. Somebody would like to know, what are your sources for premium associated with change order work?
I guess I'd like to, so is that asking, I mean, that's typically negotiated under contract, but I'm not sure what the questioner means by premium associated with change order work.
Okay, well, I will ask that person to either detail a little more what his question is or follow up with you after the webinar. Can you provide your email address or phone number so that folks who may want to contact you can do so?
Yes, we can. So Sangwoo is currently writing that on the screen so you can see it.
Aha. Great. Another question is, this individual wants to know what aspects of this research is new and where do you think the innovation in this area is headed toward?
Sangwoo, you want to address that? So the way we have sort of thought about it is, I think there's a few things that, Sangwoo, you might want to go back to your slide, the first one, go all the way back. Yeah, just right there. Yeah. So, I mean, basically the way we have sort of thought about it is that I think VDC, as you can see in this slide, provides the visibility or has provided the visibility if you can attach status to the objects, which, this system does. Lean is sort of the, getting more reliable in management of your commitments, and then the supply chain is really sort of communication and visibility. So independently, these things have existed before. I think the uniqueness about what we are doing here is the integration of those things, and also the integration of these things with our, with our ERP systems to be able to do this, almost on a real-time basis. I think, where this is going, I think we have talked about it internally quite a bit. If you look at at least the construction supply chain, there's products like door frames and hardware, which are more like the widget, which, are already manufactured, and the inventory management is a big deal. There's other sort of pre-manufactured, prefabricated things we are looking at, like drywalls and precast concrete and things like that, where this could be applied very well. We think that basically in our self-perform work, this will help us quite a bit. I think where this is sort of going in the industry, in the way we see it is, a couple things are at least what we are seeing right now. One is taking this out into the field so that the power of VDC BIM combined with the lean practices could be utilized really well by people who might not have the experience with interacting with the building information model. So that's clearly happening. The second thing we see is that it's allowing us to push for more and better management of supply chain when you really need it, like we are sort of showing in this case study. When the work is, this might be sort of a simpler example of it, but we see a lot of potential for this to go into our other sort of self-perform work activities.
And another thing I'd like to add is our last plan system and lean principles is activity-based, not material-based, which means, as you can see the image on the of the last plan system, there are a bunch of bar charts to indicate which activity should be done for a certain period. But this is not material-based, which means we cannot identify which materials and which area has not been completed. So to increase commitment of the supply chain members and of our subcontractors, we'd like to switch our practice to model-based and material-based practice directly from 3D visualization. So that's why we'd like to create some integration between VDC and Lean. However, VDC is still 3D visualization, which means we have to insert our data directly from the field into model objects to insert field data into model objects. However, VDC models can include that field data by clicking model object parameters and type that data into model object. but we'd like to utilize real-time data capturing tool to increase the speed of the data entry into model objects. So that's why we came up with this idea about integration of VDC, lean, and real-time data capturing tools.
Thank you. A few people, we've got a bunch of questions now, and a few of them are more or less of the same variety. People want to know if you wrote your own program for Last Planner, Our Plan, or did you use a commercially available program?
We have done both. So we have written our own program that manages sort of short interval planning, sort of the weekly work plans. That is a web-based program that our project teams are able to use anywhere they want. And that also works on sort of the field mobile devices. We've also worked with others that have developed an application like this before.
And kind of following up with that, this person wants to know if you could list which real-time communication tools you referenced, provided it's not confidential.
For this case study, Sangwoo, correct me if I'm wrong, but I think we used Vela. Is that right?
Yep, Vela systems.
Okay. Someone would like to know, what is the longest lead time item you included in your test?
The longest time was like a QA/QC issues. Like as you can see, the table in a supply chain, QA/QC issues are marked up on a 2D plan and with color pens, and must be entered into daily reports.
No, I think what my sense is the questioner is asking is, out of the various things we tracked, what was the longest lead time, in terms of, was it frames, was it doors, was it, that sort of stuff. So
yes, that's how I read the question.
Is that right?
I think that is what the questioner was getting to.
Yeah, so I am not sure that we have that information, but if we get the gentleman's contact, we can send that back to him. I believe it was either frames or doors, but we'll find out.
I guess so.
Great. How do you incentivize the supplier to get on board with this? This person mentions that there's going to be extra effort to supply or use the barcodes or RFID tags on their inventory. So did you have interaction with the supplier, and what was their response?
So typically the supplier have their own tracking system using barcode labels. However, that barcode label doesn't have enough information, which means like a door frame hardware schedule. We have to see in the field to check the materials. So that's why we provide another barcode labels to the suppliers to attach on each material after manufacture, and then we scan the barcode in the field once it is received to check the material received is correctly received according to our door frame hardware schedule.
And to sort of add on to that, I think what we see is some of the suppliers we work with are really large suppliers that we have not been able to influence, but there are others who are taking the barcodes and putting on it. It's still evolving, I would say. I think where we do have influences with people who we have worked for a long time and who can do that. But again, there are suppliers, especially hardware suppliers, who are much bigger, much more sort of, I would say national, much bigger than even us, and who, are not that interested in sort of, doing this for one project. So.
Okay, someone wants to know if your web-based environment facilitates receipt of information from material vendors.
So the way that web-based environment really works is once our team, our job site foremen and others have interacted and, done something with it. So let's say we change the status on receipt on the job site and things like that. So we do not have the, the field mobile devices with the material vendors. So none of the things that we show on the website get updated by anything that the material vendor does after the first delivery. So all of that is being is being influenced or changed when somebody acts DPR, be it sort of our job foreman or somebody in our shop doing something with it.
And then another thing I'd like to add is our project managers in the site, in the office, talk to our suppliers and to our vendors for production and delivery control through fax, just phone call or email. However, with this website, we can just simply give them a link to this website, and then they can check the details report to check the status of the area, of the flow, and then they can manage the schedule of the production and control, and then to minimize our inventory space on the field.
Great. Do you have any MEP subcontractors that have done anything similar to this with either duct or pipe systems?
Yes, we do. There's a couple mechanical and plumbing subcontractors that have done that on few of our projects.
Okay, thank you. What is or must be the configuration of the grid to be able to read the RFID tags from all the materials that include them? For instance, how many antennas do you use, distance between them, are they located on each floor? Basically, they just this individual just wants a little more information on the setup. And also, are the RFIDs provided by each manufacturer of each element being tracked and scanned?
So we should clarify, I think this wasn't clear early on. So we are just doing RFID right now. We haven't done it. So this case study, we use barcoding for the case study. So those issues are sort of still being figured out. One of the things that So a few things that we are currently sort of doing is evaluating which ones to use. Second thing is like putting this in our shop system. So I don't have a really good answer for the person who asked the question, but we are trying to extend this to the RFID right now. So there's no, this case study did not have RFID.
However, cost-wise, RFID tag is much more expensive than barcode label. Because like for this case study, we spent like $20 or $30 to create a barcode label for entire project. So yeah, in terms of the cost, yeah, we prefer using barcode labels to RFID tag if we have a possibility using barcode label for the material.
Well, that was apropos, because the next question was, what was the cost of the RFID tags that you were using? So I think the answer is it wasn't RFID, it was barcodes, and it was about $20 on the entire project.
Yeah, but RFID tag, as you can see, as you can imagine, RFID tag can be 10 cents to like $7 or $10 for each RFID tag, depending on this is like a active RFID tag or passive RFID tag. So yeah, so we try to minimize our initial cost of the project to utilize this system. So that's why we decide to use a barcode label, which is just $20 or $30.
And we sort of think that I think this needs to be a combination of barcode and RFID for the various sort of supply chains that we envision managing this for. So RFIDs, we are targeting probably more on the precast concrete and maybe sort of drywall components, but not door trims and hardware. It's with the cost of each tag and the amount of inventory. So just to give you an example, I think this, correct me Sangwoo, but I think this project had 223 doors, and it had each door. I mean, it was almost we were tracking about 3,000 components. And it was, would have been difficult to get a tag for each one of them. Would be cost prohibitive to do it for something like this, but definitely concrete, we think that it would be more useful. And the system works with both.
Okay, because next question was, what is the largest project in terms of number of pieces of material and or longest construction schedule that you've done this on?
currently we have a very large healthcare project, which so how big? I think it's like
$300 million.
Yeah, $300 million, and it has what, like 1,000, 1,500 doors or something like that.
Yep.
And so that's where we are targeting this. There's even a few more sort of bigger projects that we have about 2,000 to 3,000 doors on that we are going to do this on. So currently, the biggest that we have done is probably 300 doors and about 3,500 pieces of distinct pieces of inventory.
Great. Wow. This person says they've noticed that the cost seems to go up significantly with metal. Is that something that you saw as well?
So cost seems to go up with metal. Is that?
I think the metal environment with the tags.
Oh yeah. I mean, that's what we were saying is that we are still not sure that we want to use. I think we are probably sure that we don't want to use RFID for door frames and hardware. As I said, I think it's probably we are targeting that more for precast and things like that.
And then at the end of the project, we want if we use RFID tag rather than barcode label, at the end of the project, we have to detach the RFID tag from each door, from each material, from each frame, and from each hardware. But if we use RFID barcode label, we just don't have to detach the barcode label because barcode label was attached on the door hinge, which is hidden by a door set. So we don't need to do that.
Great, thank you. This question is a little longer, but a central aspect of Lean is the foreman making the promise to do the work. Does this new methodology provide too much help for the foreman? Meaning, is the assignment still a promise at the lowest level? Or said another way, does the foreman ever say no?
So, I mean, I think that's the essential tenet of the last planner system from LCI is the promise that is made. And Sangwoo described the full process. And one of the sort of the essential tenets of this system is that they are pulling inventory to the site based on what promises are being made. So yes, I would say that this is an essential sort of tenet that this system is based upon. Now, in reality, has that worked that way, to the core? I would say probably not. There's been instances where we've had maybe more inventory than what has been necessary, but I do think that for the projects that Sangwoo was talking about, especially the projects that we do in urban areas, there's a few projects going on in San Francisco where there is no laydown area. That's exactly how we envision this will work, is the promises is what pulls the inventory and you have the visibility of what's needed.
Thank you. Do the objects in the model generate the tasks needed into your R-Plan tool?
Whoever asked that question, you'd like to hire them because currently it doesn't. We would like that to happen. It doesn't do that right now.
So you know who you are. Contact them. Question.
I just sort of close that. We are actively sort of wanting to do that. I mean, basically, at the heart of that question is sort of, maybe more technical answer than needed, but really sort of how does a product model inform creating a process, which is a schedule component. And there's a lot of research that has gone into that at Stanford and other places. And we do think that some sort of a visual last planner is something that will emerge out of this. But yeah, we are actively sort of wanting to do that.
Well, this kind of plays into the next question, which is how far have you got with VDC and LPS, that would be Virtual Design Construction, and Last Planner System integration?
So we have been using coordinated building information models to essentially create commitments in our weekly work plan meetings. It's not automated just yet. There are ways you could create the commitments based on objects in a variety of tools. as I said, it's not automated, but we are using VDC quite actively in our last panel meeting. If that I sort of completely answers that, but and then this is an example. What Sangwoo showed is an example of how we are wanting to use it sort of beyond just those meetings.
And another thing to add is actually with the current last planner system, after the weekly meeting, like Monday morning or Thursday morning, Friday morning, the project managers from the general contractor should go out to the field to check the progress to identify their promise has been complete. However, without that kind of process, the subcontractors just tell us like, yeah, we complete. So please just input the 100% completion for our commitment for the last week. But there should be some validation check process. So that's why once we have a VDC model and real-time data capturing tools like barcode labels, all the information will be transparent, which means once it is complete, then they have to scan the barcode label to claim that this has been complete. So that's why we increase transparency of the last round system.
Great. Well, next question. Did you develop the bi-directional communications between the field equipment and your model, or did you have it written for you by another company?
That was, I think we worked with Vela to do that, isn't it?
Yep.
Yeah.
Okay, and then someone wants further clarification. Can you describe specifically how you connected the RFID door status to the 3D or 4D model? They're wondering if this was using the Vela tool or was it manually set up by you at DPR?
It was done using the Vela tool.
Yeah, but there is another way just to do it manually, which means once you have a 3D, like a 3D object with name parameters like 254 door or 240 frame, then those border objects will find that information from the barcode label through like an Excel spreadsheet or MS Access or etc.
So you can do it in multiple ways is sort of what Sangwoo is describing.
So Vela system is the automatic tool to do it very quickly, so that's why we utilize Vela.
Okay, great. Well, do you want to quickly just put that last slide on so that those who may have follow-on questions can contact you directly at a later date? And I want to just, as a final reminder, let everyone know that we have recorded this and we will be making it available in the FIATech Media Library later this week. So with that, I think we have concluded the questions that were sent in. I just want to thank all of you for spending the past 50 minutes or so with us, and please thank you very much, Sangwoo and Atul, for sharing your story with us. And I hope you'll all be able to join us next week for a presentation by Block on their BIM for facilities management. So thanks again, and have a great day.
Thank you, everybody.
Thank you, everyone.
Bye-bye.